Welcome to Brain Vision.
So from conservation of energy, the kinetic energy of the car will be changed to elastic potential energy by compressing the spring. So the initial and final energy is conserved, so that's why they are equal. Then we have the the kinetic part plus the potential part, and then this is before and this is after. We have again the kinetic part and the potential part. And from there, we see that initially x1 is 0, so that's why the potential part goes away. And finally, v2 is 0, so the kinetic part goes away. So we have half mv1 squared is equal to half of k x2 squared. And from there, if we solve for the spring constant, we see that this is m times v1 squared by x2 squared, which is equal to 950 kg times 25 meter per second per square there, divided by 4 meter, and then there's a square. So this thing is equal to 3.711 times 10 to the power 4 Newton per meter. Now for part B, the car will be in contact with the spring for half a period as it moves from the equilibrium location to maximum displacement and back to equilibrium. Because we know that, for example, for a pendulum or for a spring system, like if this is the spring and then if this is the mass, it compresses from equilibrium position. So the spring compresses, then it expands, and then it comes back to the equilibrium position. So that's the whole one period. Since we're just considering from equilibrium location to maximum displacement back to equilibrium, so you are just considering the half portion of the total time period, so that's why it's half t. So that means half of t is equal to 1/2 2 pi square root of m over k, which is equal to pi square root of 950 kg divided by 3.711 times 10 to the power 4 Newton per meter. So that gives us 0.5 second. Thanks for watching. I'll see you next time.